Hi guys and welcome to the A-Level Chemistry podcast. I'm a current student at sixth form. I'm doing maths, physics and chemistry, and so I've decided to create this podcast where I will be going through some of the A-Level content and breaking it down into smaller chunks to help myself and you guys with revision for our exams. This is my first time doing this, so any advice, any help, any guidance or any feedback, I'd greatly appreciate it. Just put it down in the comments below and I'll read through anything that you guys have suggested. The first topic we'll be diving into in the podcast is thermodynamics, and today's lesson will be about enthalpy changes. Now, enthalpy changes was covered in year 1, so if you're unsure or didn't quite get it, maybe it's a good idea to go through your notes before starting this podcast. Now, it's important before we start that we know what lattice enthalpies are. You shouldn't have heard of these before. Essentially, ionic lattices are held together by ionic bonds, and it takes energy to break apart these bonds, and energy is given out when these new bonds form. The energy needed to break a bond between two ions is roughly the same amount of energy that is given out when that bond is formed. So, lattice enthalpy is essentially just a measure of ionic bond strength, and there's two important definitions that need to be understood first. These are the lattice formation enthalpies and the lattice dissociation enthalpies. Now, the lattice formation enthalpy is the enthalpy change when 1 mole of a solid ionic compound is formed from its gaseous ions. For example, in the formation of sodium chloride, gaseous sodium and chloride ions come together to form a solid ionic lattice of sodium chloride. In the lattice dissociation enthalpy, the enthalpy change when 1 mole of a solid ionic compound is completely dissociated into its gaseous ions. For the same example, the dissociation of sodium chloride, a solid ionic lattice of sodium chloride dissociates to form gaseous sodium and chloride ions. Feel free to pause, rewind, and take any of them notes down. They are important and can be asked to give these definitions in an exam, so it's important that you can recall them. There are some more definitions that I will hopefully be able to put in the description, but it would be a good idea for me to read them out to you now, as they are important and can be important 1 or 2 mark questions. We did briefly see this definition in the year 1 content, but in case you can't remember, the enthalpy change of formation is the enthalpy change when 1 mole of a compound is formed from its elements in their standard states. In A2 chemistry, they introduce enthalpy change of atomization of an element, which is the enthalpy change when 1 mole of a gaseous atom is formed from an element in its standard state. This was again mentioned in year 1, but we have the first ionization energy, which is the enthalpy change when 1 mole of gaseous 1 plus ions is formed from 1 mole of gaseous atoms. The second ionization energy, similarly, is the enthalpy change when 1 mole of gaseous 2 plus ions is formed from 1 mole of gaseous 1 plus ions. In opposition to the first ionization energy, we have the first electron affinity, which is the enthalpy change when 1 mole of gaseous 1 minus ions is made from 1 mole of gaseous atoms. We also have the second electron affinity, which is the enthalpy change when 1 mole of gaseous 2 minus ions is made from 1 mole of gaseous 1 minus ions. Those are the major definitions that we need to know for the exam, and it's, again, key to remember these and make sure that these are correct word for word, as they need to be to gain 1 or 2 marks in the exam. And 1 or 2 marks is the difference between a grade most of the time at A level. This is the end to the lesson 1, so I think I will be shortly joining you for the next lesson, where we will talk about theoretical and experimental enthalpies and the purely ionic model. So stay tuned for that. I'll see you guys in the next episode of the podcast. Peace. Take care, guys. Stay safe.